Okay, this is a video lesson on acids and bases, and this will be divided into 7 parts. First part is on acid, second part on bases, third part I will talk about uses of bases and alkalines. Fourth part will be acidity in soil. The fifth part will be pH scale and universal indicator, color change of other indicators in acid or alkaline, and the last part, the 4 different types of oxides. So this is the N-level chemistry 5105 or 5107, either physics chemistry or chemistry bio syllabus. These are the learning outcomes that will be tested under the topic of acid and bases. Describe the meanings of terms acid and alkaline in terms of the ions they produce in aqueous solution and their effects on universal indicator. Describe how to test for hydrogen ion concentration and hence relative acidity using universal indicator and the pH scale. Describe the characteristic properties of acid as in reactions with metals, bases, and carbonates. Describe the reaction between hydrogen ions and hydroxide ions to produce water, called neutralization. Describe the importance of controlling the pH in soils and how excess acidity can be treated with calcium hydroxide. Describe the characteristic properties of bases as in reaction with acids and with ammonium salts. Classify oxides as acidic, basic, amphoteric or neutral based on metallic or non-metallic character. This is the O-level science chemistry learning outcomes under paper 5076 or 5078, which is physics chemistry or chemistry bio. Describe the meanings of the term acid and alkaline in terms of the ions they produce in aqueous solution and their effects on universal indicator. Describe how to test hydrogen ion concentration and hence relative acidity using universal indicator and the pH scale. Describe the characteristic properties of acid as in the reaction with metals, bases, and carbonates. Describe neutralization. Describe the importance of controlling the pH in soils and how excess acidity can be treated using calcium hydroxide. Describe the characteristic properties of bases as in reaction with acids and with ammonium salt, and classify the 4 types of different oxides, which are acidic, basic, amphoteric, or neutral based on metallic or non-metallic character. The definition of acid: it is a substance which produces hydrogen ions with a formula of H plus when dissolved in water. So as seen in this equation, hydrochloric acid, formula of HCl, when dissolved in water aqueous, this means dissolved in water, hydrogen ions is released, and this is called an ionic equation. Next, these are some of the common acids. We have hydrochloric acid, nitric acid, sulfuric acid, ethanoic acid for the O-level students. However, this is the common last topic. Let's look at the formula and the ions that is formed and dissolved in water. So hydrochloric acid, as illustrated above, the ions is H plus and Cl minus. Please memorize HNO3 for nitric acid. These are the ions H plus and nitrate ions. Sulfuric acid formula need to be memorized, H plus and SO4 2 minus. And ethanoic acid, CH3COOH. The H plus that comes out is the last hydrogen. The rest will form the negative ion, CH3COO minus. Now let's look at the physical properties of acid. First, sour taste. Second, pH less than 7. Third, acid is corrosive. Fourth, conduct electricity in aqueous solution because H plus ions can move freely. Fifth, turn blue litmus paper red and able to turn universal indicator from green to red or orange. If it is able to turn red, means it is a strong acid. Orange for weak acid. Next, we look at the chemical properties of acid. The first one is when acid react with reactive metals to give salt and hydrogen. Please memorize this general equation. Give you an example here. Hydrochloric acid reacting with magnesium metal. The salt that is produced is magnesium with the chloride that is in hydrochloric acid. So the salt name is called magnesium chloride. Hydrogen is also given out. So to make a balanced chemical equation, first change the reactants to their formula. Magnesium has a charge of 2 plus when it becomes an ion. Chloride has a charge of Cl minus. Just bring down the number without the charges. And this will give you the formula of the salt. So the salt magnesium chloride has a formula of MgCl2. Hydrogen is a gas and exists as a diatomic molecule, so H2. Now, then balance. To balance, I will put a 2 in front of HCl and everything else for the atoms will balance. Now, second example, nitric acid plus magnesium. So if it is a nitric acid, it will give a nitrate salt. So the first part of the salt name comes from the metal, magnesium. Because nitric acid has nitrate ions, it will give the salt with ending with nitrate. So again, hydrogen gas will be formed. So writing to the formula, nitric acid HNO3, which you need to memorize. Magnesium, you can check the periodic table as Mg. Now, working out the formula of magnesium nitrate. Magnesium is 2 plus, you can refer to the periodic table. And nitrate is minus, and this has to be memorized. Likewise, just bring down the numbers without the charges. You will get Mg NO3 bracket 2. Mg NO3, the whole thing inside must be bracket 2. So treat nitric ions as one group. Then when you balance, I will put a 2 in front of the nitric acid because there's 2 sets of nitrate ions. The hydrogen gas that is given out, we can test with placing a lighted spling at the mouth of the test tube. For the results, lighted spling will extinguish with a pop sound if hydrogen gas is present. The next chemical property of acid is when acid reacts with carbonate to form salt plus carbon dioxide and water. This example, hydrochloric acid reacting with magnesium carbonate. The salt name, the same, magnesium from the magnesium carbonate and chloride from the hydrochloric acid. So the salt name will be called the magnesium chloride. Carbon dioxide will be formed also, as well as water. So change hydrochloric acid and magnesium carbonate to their formula. Of course, HCl, memorize. Magnesium carbonate, you need to work out the formula. You can use the charge of magnesium, which is 2 plus. You need to memorize CO3 2 minus. Ignore the plus and minus and simplify the numbers on top first before you bring them down. That's how I get magnesium carbonate formula. Next, magnesium chloride. Mg 2 plus and Cl minus, both you can check periodic table for their charges. So MgCl2 plus carbon dioxide CO2 plus H2O. Balancing. Only the hydrogen and chlorine atoms are not balanced, so adding a 2 in front of HCl will balance the equation. Now to test for carbon dioxide, the method is to pass or to bubble the gas into lime water. The result will be a white precipitate forming in lime water. Now specifically for the O-level students, calcium hydroxide has this formula, which is also known commonly as lime water. When carbon dioxide is bubbled into lime water, calcium carbonate, which is an insoluble salt, will be formed, and it will be formed as this white precipitate. Water will also be formed here. Adding in the state symbols, lime water is dissolved in solution, carbon dioxide is gas, calcium carbonate, since it's a white PPT, will be a solid state, and water is in liquid state. The next, third chemical property of acid. When acid plus a base or alkaline, salt and water will be formed. This name of reaction will be neutralization. Example, hydrochloric acid reacting with magnesium oxide. This will give magnesium chloride salt and water. So I'm adding in how to do the workings for the formula of magnesium oxide first, and then magnesium chloride. Then change all to formula. And you try to balance it later, and you find that you will need to add 2 to HCl. Now the second part will be bases. The definition of bases: a base react with an acid to form salt and water only. Bases can be classified into soluble bases. Soluble bases are in group 1. So group 1 oxides or group 1 hydroxides are soluble base. NH4OH, also known as aqueous ammonia, barium hydroxide, and calcium hydroxide, also known as lime water, and base that are also insoluble base. Example: magnesium oxide, zinc oxide, and copper oxide. The soluble base are also known as alkaline. Alkaline is a base that is soluble in water. This will produce hydroxide ions. Formula of OH minus when dissolved in water. Example: when NaOH, sodium hydroxide, dissolved in water, Na plus ions and hydroxide ions, OH minus, is formed. Let's look at some of the physical properties of alkaline. First, they have a bitter taste. Second, the pH is more than 7. Also, likewise, conduct electricity like the acid because there is ions. They are free to move when they are dissolved in aqueous solution. It will turn red litmus paper blue, and it will turn universal indicator from green color to blue or purple. The second part, let's look at bases, chemical properties of alkaline. The first reaction is when alkaline react with acid to give salt and water. This is neutralization that has been illustrated in acid. Now the ionic equation for this reaction is H plus from the acid and OH minus from the alkaline will form water, which is H2O. The next chemical property of reaction is when alkaline reacts with ammonium salt to give salt, water, and ammonia gas. Let's look at this example. Alkaline sodium hydroxide reacting with ammonium chloride to give the salt sodium chloride. The leftover ammonium and hydroxide ions will form water and rearrange to form ammonia gas. Writing out the formula, which NaOH you need to memorize. NH4Cl, which is ammonium salt, Na plus and OH minus give you sodium hydroxide. NH4 plus and Cl minus, cancelling out the charges, give you NH4Cl. And Na plus and Cl minus give you NaCl for sodium chloride. So if you look at this equation, each of these atoms are all balanced. Now, how do we test for ammonia gas? We use litmus paper, which is red, dip it in water, so it is called damp red litmus paper. So place a damp red litmus paper at the mouth of the test tube or near the gas. A positive result is that the damp red litmus paper turns blue. Okay, the third part will be the use of bases and alkalines. Calcium oxide used to neutralize acidity in soil. Magnesium hydroxide is used in toothpaste, okay, because some of the things that we eat is acidic, and acid will corrode the enamel layer of the teeth. So use it to neutralize the acid. NaOH is also known as sodium hydroxide. It's used in making soaps and detergents. Ammonia solution is used to make fertilizers. Okay, because plants need nitrogen, and nitrogen can be taken in by ammonium salt or even nitrate salt. So ammonium nitrate has a lot of nitrogen for the fertilizer. Okay, acidity in soil. Okay, some plants grow best in neutral, some in acid, some in alkaline condition. But it cannot be like super acidic. So we can use alkaline or base to kind of increase the pH value so that it becomes neutralized or in an alkaline condition. So we can use quicklime, CaO, or slaked lime, which is calcium hydroxide. So when we add this, it will control the soil pH level by decreasing the acidity or to increase the pH value. Okay, the fifth part is pH scale and universal indicator. Okay, what it does is to show whether a solution is acidic or alkaline and neutral. So for the pH scale, if the pH value is smaller than 7, the higher the acidity due to the higher concentration of the H plus ions. Okay, this is only if it's less than pH 7. The smaller the number, the more acidic it is, the stronger the acid. For higher pH value, more than 7, the higher the alkalinity due to higher concentration of the OH minus hydroxide ions. So you have pH scale from 0 to 14. The strong acid is around 0 to 1. The weak acid is 2 to 6 or slightly less than pH 7. From more than 7 until I would say about 12, we can say is a weak alkaline. And really strong alkaline is around pH of 13 to 14. So take a look at this pH scale. You will see the color ranges from the rainbow color of red, orange, yellow, green being neutral, and then blue, indigo. We don't use indigo so much in chemistry. Just remember blue and purple or violet. So let's look at some of the color changes of some other indicators in acid or alkaline. Okay, I'm adding in the litmus paper. Red litmus paper remains red. Blue litmus paper turns red when its pH less than 7. At neutral, there is no effect on both pH paper. At pH more than 7, red litmus paper will turn blue, and blue litmus paper will remain blue. So universal indicator I have went through. Okay, there's also another indicator that is not very important in the N-level syllabus. O-level science chemistry also need not remember that much, but for your information, phenolphthalein, okay, from pH 0 to 8 points, about 8.2, it will remain as colorless, not white, it's colorless. More than pH of 8, it will be pink color. This is used in titration, so more relevant for the pure science students. Okay, for the preparation of salt in titration for N-level and O-level science chemistry students, you need to know methyl orange is used to know when to stop the titration, or rather how much volume, okay, is sufficient for the alkaline when it's added from the burette, okay, when there's a color change. So we use methyl orange as an indicator instead of universal indicator because methyl orange is more stable. Universal indicator is not. Okay, so red color when it's in acid, and it will turn yellow when it is in alkaline. So the last part is oxides. An oxide is a compound of oxygen and another element. Okay, there are a total of 4 types of oxides. If an element combines with oxygen, we call it an oxide. When a non-metal element combines with oxygen, it forms either an acidic or neutral oxide. For metallic element or a metal, reacting with oxygen will give a basic or an amphoteric oxide. So this flow chart I'm going to draw will give you how to identify whether an oxide, okay, a compound that is ending with oxide is basic, amphoteric, acidic or neutral. So if you see the first part of the name is a metal, it could be a basic or amphoteric. If it's a non-metal, it could be an acidic or neutral oxide. So basic oxides, all metal oxides except for zinc oxide, aluminium oxide, or lead-2 oxides, they are basic. But amphoteric oxides, there's only 3. Zinc oxide, amphoteric only have aluminium oxide, and amphoteric has lead oxide. As for acidic oxide, most non-metals oxides will be acidic. Only 3 that are neutral, which are non-metals, are not acidic. So the neutral ones are water, carbon monoxide, and nitrogen monoxide. So what does it mean by being basic oxide? It means that this oxide reacts with acid to give only salt and water. As for amphoteric oxide, they can react with both. Okay, both meaning amphoteric oxide can react with acid, amphoteric oxide can react with alkaline. The result is the same, they will still give salt and water. As for acidic, reacts with alkaline to give salt and water. For neutral, it do not react with acid or alkaline. So this sum up the 4 types of oxides and the whole chapter on acid and bases.